Right, hello, welcome back to another little video. So today we're going to be having a look at some optimization we can do with particles when we're having very big full screen particles. Quite often they're going to get really expensive if you're doing sand, snow, those kinds of things. Sometimes we want to do them, but big full screen, lots of fill rate, lots of overdraw, but there's some optimizations we can do to sort of help fix that. So to start with, we have here just a very basic plane, and I've got this material on it called object collapse, so let's have a look at what that's doing. So if I just arrange this, so we're taking the well position and we're subtracting the object position. So the object position is here, that's the center of the object, and well position, this is going to be calculated for every pixel in our object, and we're just subtracting one from the other. So what we're doing is we're getting a direction vector that's from the exterior point to the center, and that's everywhere on our mesh, and we're multiplying that by a value currently set to 0 and plug that into well position. So if I just quickly change this value, so if I change this parameter to 1, what you'll see is our plane has got bigger, and it's got bigger by a scale of 1. I mean, it's doubled in size effectively, and we can really kind of like scale these up. And every point on it is kind of it's pointing the direction it's moving. The direction each vertex is moving is towards the center. So if we then set this to a value of -1, it disappears. It disappears entirely. So what's happened is every vertex has worked out which direction it is to the center, and then we've moved them along that direction a value of 1, in this case -1, because we're going away from the orientation, the order we've got these around here, and that means we can now scale our object down to nothing in the material, and what's powerful about this is it's now not taking up any performance to render. If I just change this, I think if I just swap these around, I can do that with a 1 object position. Apply this, and now positive values will make it smaller. There we go. Yeah, and the value of 1 shrinks it completely. So we either way, whether you use positive or negative value here, you're scaling an object down in the material shader to reduce the overdraw, and so we can combine that with another material I've got here. This is a near fade material. So if we have a look, here's our translucent smoke, or whatever it is. As the camera gets close to it, it fades away. That's great, that stops any kind of visual popping as we move through the camera. If you're moving through a big sort of smoke cloud, fog cloud, you don't want to see particles popping out. That's a very simple thing to do. It's a function that comes with Unreal. So there's this one here, camera depth fade. It uses the pixel depth and distance from the camera, all these fun things. But all we need to do is plug in two values. So fade length, how many units does it take to fade from 0 to 1, and fade offset is how we start. So in this case I've just upped the fade offset to 256 to make it a bit clear, but the default's 24. So now 24 units away it starts fading until it fades completely out, and it takes 512 units. So let me get that right. So 512 plus 24 units it starts fading, 512 units it's finished fading, and just to emphasize that a little bit, I'll stick it up to 256. So here we start fading out, fade out, fade out, fade out, completely gone. Now the problem we've got with this, if I just load up the shader complexity, even though this has now been faded out, it's still being rendered. It's being rendered as a big, completely transparent plane. We don't need to pay that cost. There's nothing actually being useful happening here. So if we can combine these two things together, we can get kind of the best of both worlds. So here we are. We have, I can control my camera, have a plane. As I zoom in towards it, at some point it's just going to fade out completely. And as soon as it's faded out, as soon as we know that the opacity is 0, we know we're not rendering, we can just collapse it down to a single point, and we don't have to pay the opacity costs. And there we are. So this material, what does it look like? Well, it's very much what I said, just the two things combined together. So we have our depth fade, and then I'm doing a comparison. So I'm using a simple if let's reset this back to what it was before. So using the result of my camera depth fade, masking it out because we only want a single value from it, and we need to compare with a single value here. So if we compare with 0 and say if our opacity is 0, we get -1, and -1 multiplied by our direction collapses our object. If I compile that. Now you might notice there's a few different settings here that you may not have. One problem you do have with this setup, at least, don't know how easy it is to see, but as this side of the plane gets to 0, it collapses, but this side of the plane hasn't collapsed to 0 yet, so you're getting a visible hard edge along your smoke where you shouldn't be doing, or whether we don't really want that. Yeah, you can see it quite a bit clearer there, maybe. Don't know how easy that is to see in the video, but and so what we want to do, rather than comparing against 0, we want to compare against a slightly negative number. So the values that the camera depth fade will output, they've been clamped. They've been clamped inside the function. So all I've done, just duplicated the output, create a new one called unclamped, and plugged that in. Now, there's no reason why we couldn't use unclamped values in our opacity. Negative values of opacity aren't going to do anything in the shader. They're all going to get clamped there, but may as well keep it clamped if that's how it was before. But we can also create this result unclamped, and just gone in, saved that. Now, in our mask, in our material, if I recompile this so that it reflects that new value, in our comparison, rather than comparing against 0, where we're getting these kind of like little subtle errors, we can compare against, say, -0.05. So it's very so slightly. So now we've got a little bit where it fades out to 0 opacity, and then it waits a little bit before it collapses, and that just gives us a little bit of buffer so that there isn't any visible edges on the plane as it smoothly transitions out. And obviously the closer it is to 0, the more likely you are to see that error. Yeah, it's pretty invisible, really. Cool. So now, if we look at this in the shader complexity, obviously this one's not doing anything dynamically, but if we compare these two, well, you can see one of them's kind of completely disappeared. Visually, nothing, no costs. As soon as it's faded out, it's been collapsed down, no costs left. Now, I said this is useful for particles, and so how do we make it work for particles? Well, it's basically the exact same logic, but if I have here some particles, if I open this up and just apply the, well, if I just apply the object collapse, oops, I put it in the right place. So this is the one that we have to control in the material ourselves, and there's a bit of a problem. So if I set that to -1, cool, collapses down to nothing, not a problem. If I set it to -0.5, it's using the object position, so it's using the center of our emitter. So it's actually scaled the whole thing down, which isn't really what we want, is it? We want the whole thing to be scaled, or each particle to be scaled individually. So rather than using the object position, we need to replace that with particle position. Oh, position, there it is. And that's just a node, and that's just going to work the way we want. So if I go into my particle, I have already done this. I can find it. There it is, M particle collapse. Plug this one in. Like I said, it's exactly the same, just swapping object position for particle position. And now when I scale this down, we can control our particle size in our material, which is cool. No, leave that for now. Near fade work is exactly the same. That's all done per pixel distance from camera, so we don't need to change this to work with our particles. And you can see, as you zoom in, you get this fading out. But we're not getting any of that collapsing because this hasn't been updated. But excuse me. But we can totally do that. If we do the particle fade collapse, this material has the updated logic. So using the particle position, not the object position, doing the same thing with the unclamped. I'm going to set this to a very small negative number, and what we'll see is the particles will fade out and then collapse down to nothing, and we'll have a nice performant, well, slightly more performant full screen particle effect. So if I go into the shader complexity, so you can actually see this sort of collapsing happening. it's all popping out. It's not a gradual thing, but if I compare, if I just go right into this particle where things have started to pop a little bit, and I swap that material from the particle fade to, let's just say, the fade, see how much more red we've got there. So visually, no difference at all. It's resetting the emitter each time, so visually not much difference because they're both being faded out. But the difference in overdraw between having a faded out particle and not faded out particle is huge. So one to be aware of. Nice little trick. Obviously you are adding some cost, you are adding some overhead. There's definitely some maths going on in doing the comparison and this movement, the wall position offset, but the cost of this being done versus the cost of the overdraw and the fill rate on your screen is going to be much lower. So a nice little performance optimization you can make for big full screen particles. Hope that was helpful. As always, questions, comments, etc. do let me know. Big thank you to all my patrons for supporting me. I love doing these videos, so the more support I can get, the more often I can get new videos out, and the longer I can spend doing research for these. And yeah, let me know if you have any questions, and I'll see you all next time.